In this video, we will write linear equations from a given verbal description by identifying the slope and points. In the last video, we took a look at verbal descriptions describing slope-intercept form and standard form. In this video, we're going to focus on the last two, point-slope form and given 2 points. So the verbal descriptions are going to give us information that we can plug in to either one of these. All right, so first we're going to look at point-slope form. To remind you, the point-slope form is y minus y1 equals m times x minus x1. M is the rate of change or the slope, and x1, y1 is a data point. So we use this form when the verbal description gives us a data point, which means an x and a y, and the rate of change, which is the slope. So as we read this problem, at Eagle Bay, it costs $10 per hour to rent a canoe. Nick and his friends rented a canoe for 3 hours and paid $45. Write and solve a linear equation to find the cost to rent the canoe for 8 hours. Okay, so looking at this problem, we see the rate of change, $10 per hour. The rate of change can also tell us the two variables that we look at. We have dollars per hour. Remember, slope is rise over run, our change in y over change in x. So if it's dollars per hour, the dollars are going to be our y and the hours are going to be our x. That's really important to be able to identify those variables before we try and write that equation. Especially because in this form, we're given a data point. We're given 3 hours and a total cost of $45. So we're given this data point of an x value of 3 because that represents the hours, and a y value of 45 because that represents the total rental cost. Now we can use the point-slope form to set up the equation. Y minus the y value of the point equals our rate of change, m, times x minus the x value of the point. So this is writing that linear equation. This is the equation of the line in that point-slope form. Now the other part is it asks us to solve the equation when we know we want to rent the canoe for 8 hours and we want to find the cost. So 8 hours, is that an x or a y value? Well, because we've written our let statements here, we know that the 8 hours is an x value. So we're going to substitute that value in for x. And from here, we can solve for y. So we can simplify those parentheses, multiply times 10, and then add 45 to both sides. And we've solved for a y value of 75. Now let's interpret what this means. A y value in this situation represents the total rental cost. So the total cost for renting the canoe for 8 hours is $75. Our next example. Reading through the problem, a company offers premium cable for $39.95 per month, plus a one-time setup fee. Notice it doesn't tell us what the one-time setup fee is here. The total cost for setup for 6 months of service was $264.70. Write and solve a linear equation to find the total cost for 2 years of service. Okay, so our important information here. We're given the rate of change. That $39.95 is our slope. This plus a one-time setup fee. The one-time setup fee is really our b value, like for our slope-intercept form. But notice it doesn't tell us what that setup fee is. Instead, it gives us a data point. For 6 months, it costs this much. In this situation, we have our total cost, which is our y, and our number of months is our x. So it gives us that data point of 6 months and $264.70 as the given data point. So we can use that information to set up slope-intercept form. Y minus the y value of the point equals m times x minus x1. From here, we look at what it asks us to solve for. We want to find the total cost for 2 years of service. Well, 2 years of service does not mean that the x value here is 2. Because remember, we wrote our let statement and our x is in months. So we have to think about that because this is in years, we have to convert that to months. So notice I didn't plug in 2 here, I plugged in 24 because 24 months is equivalent to 2 years. So from here, I solve the equation and I get a total cost of $983.80. That means for 2 years of service, or 24 months, it's going to cost $983.80. These next 2 problems are on your own. You need to identify your x and y values as well as the slope and point. This is also an on your own problem. Once again, identify your x and y values and the slope and point from the given situation. The last type of situation is when you're given 2 data points. So in the situation, we're talking about 2 quantities, but we're given 2 sets of data. Now, this is just like given 2 sets of points to find the equation. We're going to need to find the slope first. So as we read through this example, to surf the internet for 25 minutes at an internet cafe, it costs $7.25. For 40 minutes, it costs $9.80. Write and solve a linear equation to find the cost for surfing the web for 1 hour. Okay, so what we need to do is first identify the quantities that it's talking about. Notice that it's talking about minutes and cost. So we can think about those as being our x and y values. We're going to let x equal the number of minutes and y equal the total cost. Well, if x is the number of minutes and y is the total cost, we actually already have values. We have for 25 minutes, it costs $7.25. So here we have that data point. 25 minutes is $7.25. For 40 minutes, it costs $9.80. So we have that second data point. With those points, we then need to find the slope. So we use slope formula to do that. y2 minus y1 over x2 minus x1. And then we find our slope is 0.17. We use our slope and our point to now plug into any form of the equation. So I chose to use the point-slope form. So y minus, and I picked this point, y minus y1 equals 0.17 times x minus 40. So I'm using the point and the slope that I solved for to set up the equation. Now it asks us to solve for the cost when we're surfing the web for 1 hour. Once again, notice that our x value is in terms of minutes. So we're not going to plug in 1 for x, but we are going to plug in 60 minutes. And then we solve for our y value. So the cost for 1 hour of surfing the web is $13.20. Next, we have water boils at 100 degrees Celsius and 212 degrees Fahrenheit. Water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. If the weather forecaster says it's going to be 25 degrees Celsius today, let's write and solve an equation to figure out what Fahrenheit temperature that is. Okay, notice it's talking about two quantities here. We're talking about degrees in Celsius and degrees in Fahrenheit. And we're given two data points, 100 degrees Celsius, 200 degrees Fahrenheit. We're also given 0 degrees and 32 degrees. We use these points to find the slope of 1.8, and then we use that slope and one of the points. It does not matter which point because both of the points will be on the equation of the line. Now that we have the equation, y minus 32 equals 1.8 times x minus 0, I can plug in the value of 25 for the degrees Celsius. So 1.8 times 25 is 45, add 32, and we get 77. This means that 25 degrees Celsius is equivalent to 77 degrees Fahrenheit. The next two examples are on your own. And here's the last example.